Today we're going to be learning about equations of lines. And what you're probably used to seeing when you think of a line equation, a linear equation, is y equals, for example, 5x minus 17. You're probably used to that because that's what you type into your calculator always. And it serves a specific purpose because 5 is your slope and negative 17 is your y-intercept. Maybe you knew that, maybe you didn't. What we're going to talk about today is a total of 3 different forms: general, slope-intercept, and point-slope form. And each one of these has a specific role. It makes it easier to write the equation of a line based on what you've been given. To begin, let's look at general form. General form doesn't really have a purpose except to be the default setting. When you don't know what to write, you write general form. And what general form looks like is ax plus by equals c. Now a and b, they're coefficients, numbers in front of variables, variables being the x and the y. C is just a value, a number. So if we're looking at our example, y equals 5x minus 17, that in general form would look like minus 5x plus 1y equals negative 17. So you can see that the coefficient in front of the x is negative 5, the coefficient in front of the y is 1, and the c value is negative 17. I'll show you a little bit later how we can transition from one to another, but I just wanted to throw that out there right now. So that's an example of general form, and general form doesn't really help us. Doesn't help us at all. It gives us a default, but it doesn't, if we're given anything, we can't really put it in there. It doesn't help us really. So just default. Okay? Our next one, that's the one you've probably been using a lot. Slope-intercept form. Slope-intercept form in general is written as y equals I'm going to change that into an mx plus b. Now, the m, that's your slope. And b, this is your y-intercept. And I bet you can see where the name comes from now, slope-intercept form. You're given the slope and you're given the intercept. And all you really have to do is plug those in. So for example, if I had a slope of negative 5 and a y-intercept, abbreviating intercept right there, of negative 17, for the m, I would write negative 5. Actually, let's change this to a positive 5, sorry. Positive 5, so I could get rid of this. 5x, and then plus, and my b value is negative 17. So if I were to rewrite that again, it would just be y equals 5x, distribute this negative, so it's 5x minus 17. Our starting equation. So you can see that the 5 is the slope, and the negative 17 is your intercept. All right. The purpose of this one is, if you're given a slope and an intercept, you can use it to write an equation. Where the general form, it doesn't really have a purpose. To me, it doesn't have a purpose besides it's the default setting. Next is the point-slope form. Point-slope form can be written in general as y minus y1 over x minus x1 equals m. This one has quite a bit to it because it has multiple y's and multiple x's. This first set of x and y, those are actually variables. They are going to stay x's and y's. However, these two, I'm going to draw a little arrow down here. These two are actually numbers. They're values. They're actually the point part of this. And then m, just like in our slope-intercept form, m, that's the slope. So what does this look like? Why do we use this? Well, let's say we're given a slope of -7, and we're also given the point 5, -3. How this form of a line helps us is we substitute in all that we know. Well, y and x right here, the very first ones, they're just variables, so they stay the same. But the second y and the second x, y1 and x1, those are actually part of our coordinate. And our coordinate over here, if I put this underneath, this is x1 and this is y1. So x1 is 5, and I'm going to put that in parentheses, and y1 is -3, putting that in parentheses. Then our slope right there is -7. Now the reason why we put these parentheses around our values is because there's already negative signs right here, subtraction going on, so we have to actually distribute this negative sign all the way through. And I'm just going to move my work over here. So this actually becomes positive 3, y plus 3 over x minus 5 equals -7. Okay? For that reason, you have to make sure you put the parentheses around. If you can remember it, go for it, but normally keep it safe and just put the parentheses around it so you can see that distribution. So looking back at all three of these forms, you have the general form, which it's just a default. You have the slope-intercept form, so that if you're given a slope and a y-intercept, you can generate an equation. And then, if you have the point-slope form, if you have a point and you have the slope, you can still generate an equation. Now what you're probably wondering is, are these all the same thing? Can I go in between them? The answer is yes. You can flip between different forms. And let me show you real quick how to do so. So how about, I'm going to move this up a little bit. Alright, let's pretend we're working with this very last point slope formula, which was y plus 3 x minus 5 equals -7. So this is point slope. And we want to go to, how about I write slope intercept right here, and then let's also convert it to general form in the end too. Alright, so if we want to convert it to from point slope to slope intercept, we have to write it in this fashion where it looks like y equals mx plus b. Well, we know the point slope formula looks like y minus y1 over x minus x1 equals m. For that reason, we can kind of fill a couple of our things in already, but I'm just going to have you just wait off, and we're going to actually use algebra to help us through this. So what I'd like to do is look at this, and we see that there's a y on the left side. Everything else is on the right. Let's do that with this point slope example. Let's move everything away so we only have this y by itself. So again, I'm just going to rewrite it down here. Y plus 3 x minus 5 equals 7, -7. Now I'm circling my y because that's the only thing I want on that side, so I know I have to get it all by itself. Now we typically work with the things that are furthest away from what we want by itself. We want y by itself. The things furthest away from it on this same side of the equation is the x and the -5. That's being divided. We see the division bar, so we do the opposite, which is multiplication. So let us multiply both sides by x minus 5 over 1, x minus 5 over 1. We do this because this x minus 5 right here, these are going to reduce, cancel each other out. So therefore, all we have on this side is y plus 3 over 1, which is actually just y plus 3. Anything over 1 is itself. We have to do this multiplication now, though. So negative 7 times x minus 5 over 1. So negative 7 times x minus 5 over 1. Same thing that we did right here. Over 1, it's the same value as the tops, as the numerator. So this is just negative 7 times x minus 5. Now we can leave it right there, and then we can just continue to circle our y. We want to get that by itself yet. And the only thing we have yet to do is get rid of this 3. So let's subtract 3 to both sides. So we have y. Those will go away. So we have y minus 7. X minus 5. Notice I'm keeping those parentheses there because the negative 7 is multiplied by the x, and it's also multiplied by the negative 5. But then we add a minus 3, subtracting 3 from it. Okay? And to simplify this down a little bit more, we can distribute this negative 7 both to the x and then also to the negative 5. So we have negative 7. That's fine. We'll write it in red. Negative 7x. Negative 7 times negative 5 is a positive 35. And then we have this minus 3 tacked on. So our slope-intercept form of this equation is y equals negative 7x plus 35 minus 3. That's simply plus 32. So we did it. We have our point-slope form, and it's converted into the slope-intercept form. These two things, they are equal. This one you can type into your calculator, though, and get an actual graph. So lastly, let's look at converting this to general form. General form is what we just learned. Ax plus by equals c. So we have coefficients in front of the variables, and then this is just a value, c is. So let's move all the variables to one side and leave the numbers on the other side. Looking at this right here, I'm going to move my negative 7x to the other side by adding 7x. So I will have 7x plus y, there's a hidden 1 in front of that y, equals 32. Notice we have our coefficient 7 is for the x, our coefficient 1 is for the y, and the 32 is the c value. So we took 1 and we converted between all three. Now the last thing we're going to do is one example to kind of get us off the bat with what form do we actually use. So here's our first problem. It says problem number 1, find an equation of the line through the point 1, 4 and 5, negative 2. We have three options. We can either use general form, slope-intercept form, or point-slope form. We just have to decide which one works better. General form, it's our default, it's probably not going to help us much. Slope-intercept, well, we don't really have a slope in this, nor do we have an intercept. An intercept would probably look like a number, comma 0, or 0, comma some number. That's what intercepts look like. They always have a 0 in that point. We don't have those, so we can't really do anything with it. So lastly, point slope. Well, we have points, and when we're given 2 points, we actually can find their slope. So let's go with this point slope form. So looking back at what our notes had, point slope form is y minus y1 over x minus x1 equals m, which is the slope. So let's try to figure this out now. Let's try to find what m is actually. So our slope. To find slope, we take rise over run. So y2 minus y1 and x2 minus x1. So let me just say this is x1 and y1. Oops, that's a comma. And this is x2 and y2. Okay? Plugging in, substituting in what we know. y2 is negative 2 minus y1, which is 4. x2, which is 5, minus x1, which is 1. Solving this, we have negative 6 over 4, and we can simplify that to be negative 3 over 2. So this is actually m, and we can plug that in right here. M is negative 3 over 2. Next, we have to remember that y1 and x1, they're just a point. And we kind of labeled it up here already, so let's just use x1 and y1. These first y and x, that first set, those are variables, so those are going to stay the same. So I just rewrite them. And then I put in my point. y1 was 4, x1 was 1. Notice the negative signs are there because that's part of what the point-slope form is. You need those negatives in there. And right here, we have our equation. And if it asks for general form, you can convert it to general form. If it asks for slope-intercept form, you can convert it to slope-intercept form. But that's all it asked us to do, finding an equation. It didn't say what form, so there, we're done.